Perfect. Then, yeah, I'm ready to go. First of all, hello and welcome everybody from my side. I'm Lud. I'm the head of BD at EthDA, and today I want to give you a small introduction into our project, which is a new data availability network built on top of Ethereum, and I want to demonstrate how we intend to contribute to the greater mission of scaling Ethereum. Also, I'm not here by myself. In fact, I have our co-developer, Gavin, with us, who is happy to answer any questions at the end of our presentation. Maybe to give you a little bit background and to address the data availability issue, I want to start off with some impressive numbers. And the L2 run is in full swing. And in 2023, the top 8 layer 2 chains will spend around $240 million on publishing and settling data on Ethereum. The interesting part about this is that around 90% of these costs are related to data availability. This is because there's a high demand for block space when storing this data directly on layer 1. This puts hard limitations on the scalability of Ethereum and currently represents the biggest bottleneck on the journey to achieve scalability for layer 2 based rollups. This means with increased demand on Ethereum's beacon chain, not even layer 2 solutions and chains are protected from high gas fees and lower data throughput. One solution to tackle the data availability bottleneck on the Ethereum side will soon be introduced via proposal EIP 4844, which will integrate proto-dank sharding. Proto-dank sharding includes blob carrying transactions, where blobs can be imagined as data containers that hold batch transaction data, which will be stored on Ethereum. Unlike the current state of Ethereum, this transaction data in form of blobs won't be stored any longer permanently, and in fact will be deleted after around 4 weeks. Different studies show that this proto-dank sharding can actually increase the data availability issue or actually reduce the data availability issue by increasing the throughput by around 3x. This sounds great, but considering that in the future we potentially are dealing with hundreds of layer 2s, thousands of layer 3s, and potentially even more app chains, the scaling solution provided by proto-dank sharding won't be able to compensate for the increased demand in block space and in protecting rollups from high gas fees or lower performance. An even more effective approach to scaling Ethereum is based on the further modularization of blockchain resources. In the same way, layer 2s move their execution environment away from Ethereum's beacon chain, we also can remove the data availability layer away from Ethereum by leveraging dedicated data availability networks. While Ethereum can scale like 3x, as already mentioned, via native proto-dank sharding, data availability networks, on the other hand, aim to scale the data throughput capabilities for rollups by 200 to 500x. Okay, here we go. Our solution, EthDA, identifies as such an DA network, is built as ZK rollup on top of Ethereum, and can be leveraged as modular DA layer by all layer 2s, layer 3s, or app chains running on top of Ethereum. In the final stage, it will support blob transactions and rely on a set of decentralized sequencers, which will use data availability sampling schemes to guarantee and prove blob storage via our network. All blobs published to Ethereum DA will be stored permanently and can be retrieved and accessed at any time via our blob weave data layer. And in this way, we can maintain a full history of Ethereum's chain data. What also is super important to mention is that we purposefully chose to build on top of Ethereum and not to launch as our own layer 1 chain for multiple reasons. First of all, by deploying as layer 2, we natively can benefit from the decentralization and security provided by Ethereum. Secondly, by leveraging Ethereum as tech stack, we can provide our services to other chains and builders of the Ethereum ecosystem in the most native and familiar way possible. Third, gas for transactions and blob storage can be realized via native Ethereum tokens. And last but not least, this way we can guarantee the strongest alignment with Ethereum's roadmap and vision for the future. I mean, after all, modularization is a great tool to achieve scalability, but it often imposes hidden costs on builders due to added complexity. That's why one of our highest priorities is actually to keep this added complexity as low as possible, and we aim to do that by offering the most seamless user experience provided from Ethereum builders for Ethereum builders. But that's not where we stop. Another innovative concept we are going to introduce with EthDA is by utilizing this new concept of blob storage and blob carrying transactions to actually permanently store not just roll-up transaction data, but also any kind of user data for dApps or NFTs that will be stored in form of blobs directly on-chain. By doing so, we can offer a fully on-chain storage experience and a way cheaper and way more scalable alternative to storing data directly on Ethereum. This slide is giving you a quick overview of our solution and how it works between Ethereum and potential rollups. So blob carrying transactions, including blobs, will be sent to EthDA. Those transactions can come from rollups, sending their compressed transaction data to our EthDA, or this data can come from dApps, NFT metadata storage, user storage, and can contain any kind of files. Within our EthDA network, it will be stored on our network of decentralized sequencers, where it will be guaranteed and proved via our data availability scheme. And proofs of this, the data availability, will be sent to Ethereum. Looking at the competitive landscape, we can say that EthDA is by far the closest data availability network to Ethereum's vision. We built as Ethereum rollup, and we use Ethereum as payment, and we use the same data availability scheme Ethereum is using. And on top of that, we also can leverage decentralized storage solutions. And looking at the other competitors like Celestia or Avel, some bigger competitors, Celestia is built on Cosmos, Avel is built on Substrate, and can't offer a native solution as we can with Ethereum, with EthDA, which also prepares us for the future roadmap of Ethereum to be 100% compatible. Yeah, I think I'm good in time. That's from my side. If there should be any questions, then I'm happy to answer it, or my colleague Gavin, I think you can unmute yourself as well. Thank you.
Okay, thanks, Lud, for the presentations. And now we'll have Larry to ask one question for this project group.
Yeah. Hey, Lud, it's Larry from Basis Capital. Could you please tell me more about how the decentralized sequencers work and how to make it decentralized?
Okay, Gavin, you are still here? Let me just check for my core dev. Okay, he's not there, so I'm trying to answer this. So we keep the data decentralized by maintaining the data on our set of decentralized sequencers. And for the proof of storage, we basically use the data availability scheme, which is basically the same which will be used for the full Dank sharding. We have a lot of experience with decentralized storage and keeping data decentralized, because formally we are involved in a project actually providing decentralized storage solutions, and bring this experience now to EthDA.
Yeah, I mean the sequencers, how to make it decentralized?
I think this might be a question as too technical for me, but let me see. Gavin, can you come up to the stage and maybe unmute yourself?
Okay, maybe we can communicate later.